BSS Audio's new acoustic echo cancellation input card for Soundweb London expands the Soundweb London family's capabilities into the world of high-end teleconferencing solutions. The purpose of this video is to demonstrate the performance of the AEC input card using real-time audio, video, and screen capture recorded simultaneously during a conference call. But before listening to the performance of the card, let's quickly review the components of a conference call and why AEC is needed in the first place. A basic conference call consists of the near side and the far side. In its simplest form, the near side consists of a near side talker, a microphone, a loudspeaker, a Soundweb London device with an AEC card installed, and a telephone hybrid. In its simplest form, the far side consists of just the far side talker and a phone. The two sides will most commonly communicate over a standard POTS line, although the use of full bandwidth T3 line is not unheard of for communication over short distances. The fundamental problem with this setup is that it causes the far side talker to hear echo added to his or her voice. There are two different reasons for this. The first reason is phone line latency. Let's say the far side talker speaks. This speech travels through the phone line and then exits the loudspeaker on the near side, incurring latency along the way. In North America, the typical one-way latency within landlines is approximately 50 milliseconds. Upon exiting the loudspeaker, the speech is heard by the near-side talker as designed, but it also enters the microphone directly and transmits back, incurring another 50 milliseconds of latency on its way. As a result, the far side hears an echo 100 milliseconds after the original speech. Using cell phones or VoIP services will cause an increase in the latency and therefore the length of the echo. The second cause for echo is acoustic reflections in the near side. Again, let's say the far side talker speaks. This speech travels through the phone line and then exits the loudspeaker on the near side. In addition to directly entering the microphone as previously mentioned, the speech also reflects off the various surfaces in the room before entering the microphone. As a result, the far side talker hears an indirect, room-colored echo. The echo heard by the far side talker can seriously hinder effective communication during a call. Fortunately, BSS Audio's new AEC input card provides a perfect solution to this problem. While the sophisticated processes by which echo is removed are beyond the scope of this video, the fundamental goal of AEC can be stated simply: to prevent any far side speech from returning to the far side. While the far side receives the primary benefits associated with the AEC input card, the near side also indirectly benefits from the overall improvement in communication during calls. In addition to echo cancellation, the AEC input card also provides powerful features such as noise cancellation and automatic gain control. These features will also be demonstrated during this video. To demonstrate the power of BSS Audio's new AEC input card, let's call an outside line over a standard phone line.
Hello.
Hello. Now let's take a look at the AEC input card's default control panel within HiQNet London Architect. At the bottom of the control panel, there's a phantom power on-off button, a preamp gain fader, a signal level meter, and meter controls. In addition to these controls and meters, which are exactly the same as those seen on the regular analog input card's default control panel, there are also controls and meters specific to AEC at the top of the control panel. The AEC on-off switches turn the AEC algorithm on and off per channel. Each channel also has an auto gain control on-off switch, noise cancellation level controls, and non-linear processing level controls. More on these controls later. Let's take a look at the ERLE meter. ERLE stands for Echo Return Loss, and it's defined as a measure of the coupling between the AEC reference signal and the AEC input signal. Alternatively stated, it's a measure of how loudly the voice from the far side is coming out of my loudspeaker and then entering my microphone. It can also be thought of as a measurement of how hard the AEC algorithm needs to work to remove echo from the signal path. ERLE stands for Echo Return Loss Enhancement, and it's defined as a measure of the loss through the linear AEC algorithm. Alternatively stated, it shows the direct echo being removed from the signal path. As you can see, the AEC is currently on, Let's hear how it sounds on the far side, because remember, that's where the benefit occurs. Okay, we're now hearing the audio from the perspective of the far side.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sounds great. I'm not hearing any echo.
Great. Now this time, when you hit the number 5, I'll turn off the AEC, and you'll hear what it sounds like without the AEC card removing any echo. So go ahead and count, far side.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm definitely hearing echo now.
Irritating, isn't it?
Yes.
Okay, so now I'll turn the AEC back on when you hit the number 5. So go ahead and count again.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, the echo is eliminated almost immediately.
Precisely. Now let's jump back to the perspective of the near side for a moment. Okay, we're back. The echo was eliminated so quickly due to our blazing fast convergence rate of 49 dB per second, an industry best. A fast convergence rate is particularly crucial when something physically moves and changes the acoustic characteristics of the near side room, because that means the algorithm must then reconverge to eliminate echo. One of the best examples of a changing environment is when the near side talker, that's me, moves the microphone around the room. This is especially common with wireless microphones. To simulate this, I'll pick up my microphone and move it around the room. But first, let's jump back over to the perspective of the far side. Alright, so this time the far side will count to 20, and I'll move the microphone around the room during the count, and let's see how it sounds.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Sounded fine throughout.
Great. Now let's jump back to my perspective for a moment. Okay, now let's talk about ERLE a bit more. Traditionally, AEC algorithms are incapable of removing echo from the signal path once the ERLE surpasses 0. But BSS Audio's uniquely powerful frequency-based algorithm allows for full operation at up to +10 ERLE levels, an industry first. To demonstrate this, I'll move the mic absurdly close to the speaker, and I'll also turn up the speaker itself. But first, let's jump back to the perspective of the far side so we can hear how it sounds. Okay, so I'm now moving the microphone and turning up the loudspeaker. So go ahead and count, far side. Give me a count to 20.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Wow, it still sounds fine.
Great. Now just for kicks, I'll turn the AEC off when you hit 5. Go ahead again, far side.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that sounds awful.
And now I'll turn it back on when you hit 5. Go ahead.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sounds great again.
Great. Let's jump back to my perspective. And I've just moved the microphone back to its original position. Okay, so the implications of this extended ERLE operating range are tremendous. This means that installers can now set up conference rooms with virtual disregard to mic-to-speaker placement, the use of wireless microphones, varying gain structures between calls, or individuals tampering with the loudspeaker volume settings. Alternatively stated, users will have a harder time breaking the system, and installers will therefore receive fewer complaints and callbacks. Now let's talk a little bit about nonlinear processing. Nonlinear processing, NLP, is used to eliminate the secondary, indirect type of echo or reverb that is caused by the acoustic reflections in the near side room. Traditionally, the NLP level must be carefully tweaked until achieving a delicate balance between best double talk performance at 0% and best elimination of indirect room-colored echo at 100%. The specific NLP level at which these two performance factors are optimized is often referred to as the sweet spot. Fortunately for installers, BSS Audio's uniquely powerful AEC algorithm also gives the benefit of having an extremely wide sweet spot. This means that for almost all room types, installers can simply leave the NLP set at the default value of 50% and still achieve optimal performance of double talk and indirect echo elimination. Let's listen to NLP's effect on both of these features by jumping over to the far side's perspective.
Okay, let's hear what it sounds like without any NLP. When the far side hits the number 5, I'll set the NLP to 0%. Go ahead, far side.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I can now hear the echo created by the acoustics in your room.
Okay, now I'll set it back to 50% when the far side hits the number 5. Go ahead, far side.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sounds fine now.
Great. Now let's try double talk. I'll say my ABCs, and the far side speaker will count to 10. Go ahead, far side.
1, 2,
A, B,
3,
C, D, E,
4,
F, G, H,
5,
I, J, K,
6,
L, M, N, O, P,
7,
Q, R, S,
8,
T, U, V,
9,
W, X,
10.
Y, Z.
Sounded great. There was no gating.
Great. Now let's jump back over to my perspective.
Okay, now let's talk about noise cancellation. The noise cancellation is yet another feature that's benefited tremendously from BSS Audio's powerful AEC algorithm. It's used to eliminate steady-state background noise, such as noise from HVAC systems, projector fans, equipment fans, etc. In this case, we'll simulate background noise by blasting white noise out of my loudspeaker. It's also worth noting that the noise cancellation has a range of 0 dB, which is off, to negative 25 dB, which is the most aggressive setting. So let's now jump over to the far side's perspective.
Okay, so now I'm going to turn the noise cancellation off, which again is set to 0. And now I'll turn the white noise on. Do you hear that, far side?
Yes, very clearly.
Great. Before doing anything else, let's jump back to my perspective, just to hear what it sounds like in my room.
So this is what it sounds like in my room. Okay, so it's pretty loud. Now let's jump back to the far side.
Okay, now I'm going to count to 10 this time, and when I hit the number 5, I'll set the noise cancellation to negative 18. The noise will then vanish, but the tone and level of my voice will remain the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How's that sound?
Wow, the noise is gone.
Great. Now let's jump back to my perspective.
Okay, so as you can hear, even though the far side isn't hearing the noise, it's definitely not because I turned the noise off. It's just the noise cancellation removing it from the signal path. So let's turn the noise off. Okay, now let's talk a little bit about auto gain control. Auto gain control is designed to compensate for varying distances between the near side talker, that's me, and the microphone. To access the AGC controls, click on the Advanced button at the bottom of the control panel. The AGC meter shows how much gain is being added or taken away from the microphone signal. For a detailed overview of the other AGC controls, please consult the help file within HiQNet London Architect. Now let's jump over to the far side's perspective.
Okay. To demonstrate the benefit of using AGC, first I'll leave the AGC off and I'll move where I am in relation to the microphone, speaking at a consistent level the entire time. Then I will repeat the process, but with AGC on. So to start, I'm speaking at a normal distance right now at a normal level. I'm now leaning into the microphone. I'm now about 1 inch away from the microphone. Now I'm leaning back, leaning back, leaning back. I'm now at a normal distance. I'm now leaning back even further. leaning back all the way in my chair, and I'm about 5 feet away from the microphone. Now I'm leaning forward, and I'm back at a normal distance. So let's go ahead and try that again, but this time with auto gain control turned on. So now I'm speaking at a normal level, at a normal distance. Now I'm leaning into the microphone, and now I'm about 1 inch away from the microphone. Now I'm leaning back at a normal position now, and I'm leaning back even further in my chair, leaning back, and I'm about 5 feet away from the microphone right now. So I'll leaning back to the normal position, and I'm back. How's that sound?
Your speech levels were much more consistent with AGC on.
Great. So that concludes the demonstration of BSS Audio's new AEC input card for Soundweb London. For more information, please visit www.bssaudio.com.